Excellent. Well, welcome. We're here with Chet and Romain. This is sort of what we've all been waiting for. I know I certainly have been waiting for it all day. We're really excited to have you both here. How are things for both of you right now? You awake yet?
Yeah, no, it was good until you put a lot of pressure on us by saying that you were all waiting for us.
Things are very early here. That's how they are.
Well, of course, I mean, when I was just talking to Chet beforehand, he assumed that the show was just getting started. Now, I don't know if that's just that now that he's here, the party can really start, or if, no, we're happy to have you both here. Really appreciate you being with us today. I'm going to sign off, but I wanted to do a little bit of housekeeping first. For anybody who's joining us, as you know, if you've had experience all day, you'll know that there's the Slido link embedded into the browser here. Feel free, while Chet and Romain are talking, to put your questions in the Slido. We're serving sort of as the warm-up act right now for Android Summit, which is taking place in New York in about an hour, where Chet and Romain are going to be also doing this keynote as well. So we're the guinea pigs. We hope they don't screw it up too badly for us and get it right for Android Summit, but we'll see how it goes. But that said, we're going to, they've got a hard cutoff. So, but, no worries. You can still ask your questions. We're going to archive them. We will pump those questions in tomorrow during the panel. We have the Ask a Googlers panel on modern Android development. So feel free. Don't be concerned if Chet and Romain don't have time to answer questions today. You'll be able to hear it tomorrow. You guys have a hard cutoff, so I'm going to sign off, and the room is yours.
Awesome. Thank you. Yeah, there's some bad habit that we have of like back-to-back droidCon EMEA events. Last year it was speaking at Android Developer Summit and then hopping on a plane and getting off the plane and speaking at droidCon. And this year it's sort of in reverse.
It's a little easier without the planes, though.
Yeah, I think at least we'll make our connection this time. So good. Why don't we dive in? We have a solid amount of content. And as Greg said, then we got to run. So welcome to Modern Android Development. I'm Chet Haase from the Developer Relations team.
I'm Romain from the Android Toolkit team.
And we are going to talk about modern Android development again. So it turns out we've actually been talking about this thing for at least a couple of years, 2.5 years. We gave a presentation at Android Makers in Paris back in 2018, followed by another presentation at Devoxx France, I think the following week, also in Paris. And then we spoke about it at Google I/O in 2018. We talked about it in October at the Android Developers Summit. I think we spoke about it in Greece. Did we also do it at droidCon UK? I could not remember.
I'm sure we did.
But this time we mean something slightly different. At the time we were saying, we used to do some things and now we do different things, and let's, do sort of a before-after comparison. But now we use the phrase internally and apparently externally to explain the things that we want people to understand about Android development today. The tools and the libraries and the practices that you should adopt. A lot of these are optional, but we really recommend that you use them. And so we want to try to paint a cohesive surface area over what those things are. First, let's talk about classic Android development.
All right, then we're going to start with a quick history lesson of how Android, as we know it today, was born. So sometime in late 2007, we released our first public SDK. It was called M3 for Milestone 3. Who knows what happened to 1 and 2? They were never made public. And M3 contained everything that is still the foundation of Android development today. So using the Java programming language, our platform APIs with the intents and bundles and activities and things like this. On the developer tools front, we're going to talk about this a little bit more, but we're using not IntelliJ, not Android Studio, but Eclipse. We had a plugin for the Eclipse IDE. And finally, APKs were already our form of distribution for applications, but they were a lot simpler than they are today. Then about a year later, we shipped Android 1.0. And then for many, many years, according to this graph, we didn't do anything. And then suddenly Android Studio appeared. So that was our first shift towards what we call modern Android development. We completely changed our developer tools, and it served as a new foundation that we still rely on today. Then in 2017, so a couple of years ago, we announced support for the Kotlin programming language that was mostly driven by what you, the community, told us you wanted. And we've been very happy with this decision. We also introduced a new series of libraries called Arch components that are part of Android X. It's turned into the bigger Jetpack umbrella. So now we have over 80 libraries or more that are part of Jetpack. They cover a large number of things. And finally, add bundles that Chet will talk about some more at the end.
Before, when we first came out, we had, of course, the Java programming language for many, many good reasons. Many developers, most developers, were already working with Java, so it was an easy transition to use that language on this new platform. A lot of the tools for developing with that, including Eclipse, were free, and free is the best price. There were a lot of ways that people wrote code in Java programming language that they could continue doing in this new platform. Different APIs, of course, but similar practices and some middleware and libraries and utilities that people would use. And so they could just transition all of that stuff over to the new world. This was, of course, one of the new languages at the time that handled memory management automatically. So you didn't have to deal with manual allocations and freeze and just tracking your memory very carefully as you do with the native languages.
So we mentioned Eclipse. Some of you may have never used it, but Eclipse was and still is a very popular IDE in the world of the Java programming language. When Android started, we wanted to have something that was as inclusive as possible. So a big part of this was using tools that people were already familiar with, and more importantly, tools that were free. So anybody could get started developing on the Android platform without spending anything, right? You could just download the SDK, download Eclipse, and then you could start creating applications and distribute them. So the fact that Eclipse was free was a huge deal for us. Eclipse also is a plugin platform. So this allowed us to create our own plugin. So that was ADT for Android developer tools. And this allowed us to integrate, for instance, our provider. We could integrate support for Android Manifest and so on. So we could provide a somewhat cohesive experience within the IDE. And of course, just to make that point very clear, it was free, which is nice.
In the previous worlds, classic world of Android, we had all these APIs that you could use basically on the platform, right? They were talking about platform APIs that would be updated for users whenever they would update a release on their device. We had releases frequently, really, really frequently. At times, the team was working on at least 2, sometimes 3 releases in parallel. Just because the timing was so tight there. There was one year where I think there were 4 releases in the same year, couple of them within a month or 2 of each other. There was a lot of new sort of startling functionality in every release as the team was sort of playing catch up to where devices and capabilities really needed to be for the users at the time, given what they were trying to do. There was constant bug fixes coming out because, of course, new platform, you put in all this new functionality, maybe there are some issues that you need to fix along the way. If you take a quick look at the timeline of that stuff, 1.0 came out in late 2008, followed quickly by 1.1. 1.5 was the cupcake release. 1.6, all of this is happening in 2009. 2.0 also in 2009. 2.2 gingerbread release at the end of 2010, and then 3.0, and then finally we got into sort of an annual cadence, kind of slowed down to once a year, which was really the desire of not just the platform team but also the manufacturers and device makers. It's a little bit easier for them to consume them when they're not coming out so quickly, and developers as well, like having to learn all this new stuff on such a frequent basis was a little bit tough. So now we're on more of a regular treadmill of annual releases.
So APKs, like mentioned previously, of course, that's to distribute your application. APKs or Android packages are just fancy zip files. They're just a zip file with a few files inside that the Android system expects to see, like the manifest and your dex file. One of the issues that, when we introduced APK, it was all well and good for the simpler applications back then that had just basically one configuration. And even when we started adding support for more displays, it was still fairly easy to build your app into a single APK because you didn't have that many resources and there were not that many configurations to handle. Of course, over time, this evolved, right? Like now, then we had tablets, we had multiple screens with very different capabilities. Different ABIs, so different types of CPU architectures. Now we have TVs and we have watches. large number of things that you need to put in your APKs. So the problem is that putting all those things in the APKs means that either you have to split your app yourself into multiple APKs, and it's very difficult to handle, or you need to have just one giant APK, and that means that someone who downloads your APK onto their phone will have to download a lot of data that they will never ever use or even need, which is an issue.
So with all of these classic approaches to building Android applications came a bunch of classic problems. On the language front, as we talked about, we have the Java programming language. It's still an awesome language. The platform is still built completely around this language. All the APIs are in Java, no intention to move away from that. It's still good, but in terms of modern languages, it's a bit verbose. The amount of code that you have to write to do canonical, frequent operations tends to take a lot of code.
And on the tools front, so it was nice to have access to Eclipse and being able to write plugins, but the tools team found it very difficult to customize Eclipse. And of course, the needs of the Eclipse platform, the direction the Eclipse platform was taking were not necessarily aligned with ours, and we didn't have a lot of influence over Eclipse. So it was very difficult for the tools team to achieve their own goals. On top of that, the tools that we could integrate into Eclipse were somewhat limited in the integration they could do, at least with the team that we had. And there was a benefit, like those tools could be made to be standalone applications because of Eclipse as a platform. You can actually run the Eclipse platform without the IDE bits. But this meant that we had inconsistent UIs between different parts of our plugin. And more importantly for us, there was a shift in how Eclipse was being developed. It was very successful as a platform, so there was a lot less emphasis put on Eclipse as an IDE for Java developers, and it was not improving as actively as we were hoping. And like I mentioned before, we didn't really have any influence and even less control over that, so this was becoming an issue for us.
So with the previous approach to APIs, basically all in the platform is very powerful, very consistent. You always had one place to look for all these things, but the developers were limited in terms of what they could take advantage of, both in terms of functionality as well as bug fixes, by knowing what releases their users had. So maybe they could get their latest release to develop with, but they weren't sure that the users were actually getting those releases on their devices. So it was difficult or demotivating to actually adopt new technologies, because why spend your time on that thing if so few of your users are going to get that? Because most of your users may still be on older releases and you don't really have any control over when they can update those devices. Also, some of the APIs were complicated, and this is somewhat necessarily the case because, frankly, you can do so much on mobile devices, right? It's not just writing a desktop utility somewhere. It's writing this application that can do everything from local storage to cloud storage, communication stuff. You're working with, limited bandwidth and limited CPU and GPU, and there's just all these complicating factors in the world of possibilities that you have on a mobile device. And so that necessarily then got integrated into some of the approaches and practices and APIs that we had on the platform. And there are some areas like lifecycle and storage and navigation that tended to be complex for developers to integrate with and continue using on an ongoing basis to write these robust applications that they needed on the mobile devices.
So APKs, the problem with them, I just mentioned them, right? Like either you had to have a monolithic APK to handle all the possible configurations that your app supports, or you had to split it into multiple APKs, and that's a complicated process and it's a lot of maintenance. So obviously we can do better than that.
And so our answer increasingly on the platform team, on the Android team, is what we are now calling modern Android development. And I'll just go ahead and read this quote here because I thought deeply about these words and why make up new ones. Development tools, APIs, language, and distribution technologies recommended by the Android team to help developers be productive and create better apps that run across billions of devices. So there are 4 areas that we talk about there, and that is not a coincidence. We're going to talk about 4 areas here. We're going to talk about the areas of language, tools, APIs, and distribution, and what we offer in these areas and what we recommend that developers use. And then all of this sits on top of the foundation of using all the core technologies in the platform and Play Store technologies for distributing your applications. We're assuming that you're using that. What we're doing is layering these other things on top that we recommend that you also use, or in many cases use instead of the core platform technologies. So first of all,
so Kotlin, I would love to make you raise your hands to know how many of you are using Kotlin. So I'm going to assume that about 70% of you are using Kotlin. That's
100% of the audience you can see.
Can we say that you're using Kotlin? I'm not so sure, Chet. Anyway, so a quick timeline about Kotlin. So Kotlin is a project that's driven by JetBrains, the company that's behind IntelliJ and other IDs. And Kotlin started, I think, something like 6 years ago. But version 1.0 was released in 2016. And Kotlin was already making a bit of noise, and we had certainly been looking at this. A lot of folks in the community were already interested. But it took us only until mid-2017 when at Google I/O we announced that we wanted to officially support the Kotlin programming language on the platform. For us, the main point was to guarantee that we would not break users of Kotlin whenever we released a new version of the SDK or the IDE, and that we would fix any problem that would come your way. But then we started, using Kotlin more and more ourselves over the next couple of years. A lot of some first-party apps and a lot of third-party apps have been using it. We started using it internally as well for some of our libraries. So in 2019, last year at Google I/O, we announced that Android is going Kotlin first. So we really try to adopt Kotlin wherever we can as a first-class citizen. And you may have seen some of the results already in Jetpack. So for instance, Jetpack Compose is written entirely in Kotlin, and it's going to be our next generation UI toolkit. And yeah, also coroutines. Earlier this year, I don't remember when, we officially said that coroutines are recommended way to do to schedule things either in parallel or to do asynchronous programming. So why Kotlin? So for those of you who have never used Kotlin, there are multiple reasons. Those are some of the 4 more important ones. So it's a very expressive language. We're going to look at some example. You have null type safety. You have interoperability with the Java programming language. That was very important for us. You can access all the existing Java APIs that we offer, and you don't have to write any kind of glue, and you live in the same address space and same memory chunk as your regular Java programming code. Which avoids a lot of overhead. And structured concurrency, so that's what you get with coroutines. It's a much easier and cleaner way to write your code. So if we look at a very simple example of Kotlin, again, if you're already using Kotlin, I don't need to convince you, but the first example that we see here in the onCreate function is this question mark as part of the type. So that means that the type can be null, so it makes it very easy at compile time to catch potential null safety bugs in your code. Then we have lambdas. Lambdas are not especially new. They already exist in the Java programming language, but Kotlin does offer this really nice syntax for lambdas. So training lambdas when they're the last parameter of a function, you don't need to put it in the parentheses as a parameter. Instead, you can just open the curly brace and put the code of the lambda right there. And this has proven to be extremely beneficial to projects like Jetpack Compose, for instance, when we rely heavily on this to offer a nice and clean API. Extension functions are kind of syntactic sugars, so they're a way to add APIs to existing types. So it's great for us to be able to extend the capabilities of the platform, but they're also a good way for you to organize your code. You can keep your types as simple as possible and keep all the APIs separated in different modules, so you only import what you need. Template expression, again, this is not new and not specific to Kotlin by any means. Other programming languages do this, but it's much easier to be able to put expressions directly into your strings without having to do this dance of concatenating strings and expressions. Properties, so you have a nice syntax for getters and setters. You can customize them, but again, makes your code cleaner and easier to read. And of course, this full interop with Java, where if you have a get and a set method, you'll be able to use the property syntax for those. So another reason we really like Kotlin is speed. And here we're not talking about speed, like runtime performance. We're talking about the speed of you writing code or reading code or maintaining code. It's all about your workflow. So some stats, the reason why I said that most likely 70% of you would have raised your hands, it's because we know based on our surveys and analytics on Play Store that 60% of Android developers who do this professionally already use Kotlin. And of the top 1,000 most downloaded apps on Play Store, 70% of them contain some amount of Kotlin code. And over time, that amount is growing. So what do we do with Kotlin internally at Google? So first of all, on the tooling side, we've been adding lint checks to help you use the Kotlin best practices and to avoid potential issues. There are some gotchas with any language or any API. We do have a dedicated compiler team. So JetBrains is working, of course, on the Kotlin compiler, but we have folks at Google who are doing the same to help the JetBrains team move as fast as possible. And it's the same team that works on R8, the application optimizer. So they've created Kotlin-specific optimizations in R8. For instance, when you decompile Kotlin bytecode, you may notice that some forms of loops create bytecode that's not completely optimized, and R8 will take care of that. We've also been working on a new solution for annotation processing. So we have this new thing called KSP, the Kotlin Symbol Processor, and it's a faster alternative to KAPT if you need to do annotation processing in your Kotlin code. We're also trying to help Kotlin users with the existing APIs. So specifically in the platform, we've been adding the nullable and non-null annotations that help Kotlin developers and the Kotlin compiler figuring out the null safety of different APIs. We also use recently nullable and recently non-null. So when we use those, for instance, when we add an annotation to an API, we use the recently variants. It will only give you a warning if you don't, for instance, if you pass null to something that says recently non-null. And then we switch those annotations to nullable and non-null, and then you start getting errors. So it's a way for us to help you get ready for the change in the API. One of the first things we did after adopting Kotlin was work on the Kotlin extensions library. So those rely heavily on things like extension functions to be able to improve platform APIs outside of the platform itself. So they are effectively a series of small utilities that make the platform APIs feel more Kotlin native. That's one way to say it. So we're going to take a look at an example right now. So here's our regular bitmap API. So the way you create a bitmap is you call the static function called create bitmap. Then let's say that we have a drawable and we want to render that drawable into the bitmap. So we're going to use the draw method on the drawable. And finally, in your application, you would have to write code that looks like this. So first of all, you need to get the bounds of the drawable, and you can see that we destructure it. Actually, I think that's only possible thanks to the Kotlin extensions. Then you need to set the new bounds that you want on the drawable. Then you create your bitmap. You pass your configuration. That's going to be ARGB 8888 99% of the time. You draw your drawable on a canvas that wraps the bitmap, and finally you restore the bounds. So that's a lot of code that you have to write. With the Kotlin extensions, we have a 2-bitmap function, extension function on drawable itself. And you can see it's using default parameter values so that for things that are common, most of the time you want to draw your drawable at its intrinsic size, you don't have to specify the width and the height. So all the code that we wrote in the app just turns into this. You call mydrawable.2bitmap. You specify the width and the height, but that's optional, and that's it. You're done. So there's no magic. It's all things that you could do yourself. They're just convenient APIs to make your code a lot easier to read. On the library front, we're also adopting Kotlin as part of our APIs more directly. So for instance, in Room and Work Manager, we have support for coroutines. Our new paging 3 library is a complete rewrite of the paging library in Kotlin. And of course, there's Jetpack Compose that I already mentioned that not only is written in Kotlin, but had to be written in Kotlin because it relies on a compiler plugin to be able to add all the reactive capabilities to Kotlin directly at compile time. And finally, we also do as much as we can to help you learn Kotlin and learn the best practices. So we work on documentations, we have samples, we have code labs for people who want to get started. We have different courses. We write articles. The DevRel team has been producing a lot of videos. So recently, Florina has been driving this Kotlin vocabulary series, which is a great way to learn Kotlin one piece at a time. Now to tools. So Android Studio, our current IDE. So if we look back at our timeline, Android Studio was announced and released in 2013 at Google I/O. And for a while, it was being developed while we were still supporting our Eclipse plugin, ADT. And finally, like about 4 years later, so when we announced Android Studio 2.2 with the new constraint layout editor, we deemed that Android Studio was now good enough and had enough features that we could deprecate Eclipse. That also meant that we gave you 4 years to be able to transition from Eclipse to Android Studio. And also by then, ADT was under maintenance and was not getting any new features anyway. So the writing had been on the wall for quite a while. 2.2 was fast followed by Android Studio 3.0. That's when we introduced, when we made support for Kotlin official. We added a number of profilers, so CPU profiler, memory profiler, network profiler. In 3.1, we added D8. It's a new way of compiling your text files. It's more efficient. We added then more profilers, like Systress is now directly integrated in the IDE. We have the energy profiler. In 3.3, we saw the new navigation editor. So it's kind of like constraint layout where we built the library with the tools in mind, and we built them together so we could release something that felt like one cohesive solution. In 3.6, earlier this year, we added view binding, which is you can see it as a pared down version of data binding that's really meant only to replace your find view by ID calls in a type safe way. And it's also Kotlin friendly. And 4.0 saw the addition of motion editor, which extends what the constraint layout editor can do, but except it's all about animations. And of course, because we're based on IntelliJ, we have all the benefits of the IntelliJ in its platform. So we have the powerful code refactoring. It's very easy for us to extend the UI. We can tightly integrate our tools inside the UI. We have tight integration with Kotlin, obviously, because it's being developed by JetBrains themselves. Gradle has fantastic support inside Android Studio. We have the lint checks, the quick fixes, and of course, just like I mentioned, things like navigation, data binding, the database explorer are now being developed in parallel. Like we develop the libraries and the tools in parallel to offer the best integration possible.
All right, enough about tools and language. Let's talk about APIs. When we talk about modern APIs, we're basically talking about Android Jetpack, or more specifically, a subset of Android Jetpack. As Romain said before, Jetpack is over 80 libraries right now. It's not all of them we're talking about. All of them are good to use, but we're really talking about the subset that specifically make it easier to write and maintain Android applications. So modern APIs, you can think of it as this. I see constraint layouts, the 1.0 sort of being the first step in this direction, sort of drastically simplifying what was a very complex part of designing the UI for your application. Then architecture components was the next huge step. Lifecycle, view model, room, and then other libraries in the years since. And then Google I/O, we announced Jetpack. This is basically what a bunch of this stuff existed, like architecture components, constraint layout, and we kind of bundled it together and said, okay, this is what we have in mind for Jetpack. This is the surface area of unbundled libraries where we're going to put these, as well as some guidance and best practices about using this stuff. And then we also introduced the paging library for paging data in a more performant way into Recycler view, navigation, as Romain mentioned already, and work manager for scheduling and executing deferrable jobs. Material design components then came out, and we've done a lot of work with that since, making it easier to integrate that UI expression into your applications, and these components that come with a lot more built-in capabilities as opposed to design guidance that maybe developers needed to figure out on their own. At the next Google I/O, we talked about Jetpack Compose. That was the introduction of this, and we started developing that in the open. It was pre-alpha for many months and is now alpha. We also introduced Camera X, making it a lot easier to develop camera applications, especially for the wide ecosystem of devices available in the world. And then Motion Layout plus the editor that was developed in tandem with it came out more recently, making it easier to do not just UI layouts, but also the animation of those layouts as you transition from one state to another. So Constraint Layout is, of course, this tool and this library that allows you to do. I think of it as sort of relative layout plus plus, where you have the ability to define where these items are in relation to each other, but you can also define other things like guidelines in the UI, so you can automatically sort of build in the padding that you want around the edges of your application, or the grid that you want to lay UI items out on, just simplifying designing UIs overall, especially with the inclusion of the extra tool. Then motion layouts builds on that. It's a subclass of constraint layout, and you can think of it as transitions on steroids. It's the idea that we had with the transitions API of you have a before and you have an after, and motion layout allows you to automatically go from one to another, but more importantly, to customize the animation that you use to go from one to the other, and to interact with user interactions at the time as well, so they could sort of scrub. You can think of them as scrubbing the animation between those before and after states. Life cycles, originally, you had to sort of get this entire diagram, in fact, something more complicated, inside your head and really understand it quite deeply. Not only that, but you needed to override activity or app compat activity, subclass that, and then override all of these methods to really figure out at any given time what lifecycle state your application was in, your activity was in, because otherwise you may end up leaking or crashing by making the wrong assumption at runtime. And so you ended up necessarily putting too much code in the activity, because that was really the place where you get this information. So we moved to a new model. You should still kind of understand what's going on with lifecycle, but not at the deep level that was necessary before. Instead, we have this idea of actually being able to observe the life cycle, and then you can query that life cycle at any stage, and you can also get messages about when that life cycle changes. So then you can just find out what's going on, or be told what's going on, without actually overriding and putting too much logic and code in the activity itself. So then we end up with architecture, something more like this, where we have a really nice separation of capabilities between the UI that really shouldn't be managing the data, and the data which really shouldn't be managing the UI. So on the data side, you have this view model, you have some live data objects there, and you can observe these objects from the UI, and then you can get these callbacks and find out when things changed, and then you can make the appropriate changes in your UI based on that. We assume that you're probably sitting your data on top of some sort of database. Maybe you are using SQLite, and maybe there's a DAO that you're using from Room that sits on top of that thing. And then you can use interfaces like this. So you have this DAO, you have Kotlin coroutines built into this capability. So you have these suspend functions. So now all of a sudden, instead of figuring out this complicated mechanism for having these asynchronous calls, because you can't do database manipulation on the UI thread, really bad thing to do in general. So what do? Well, I need to get over to another thread, and then I need to have a callback when that's done, and you end up with this sort of asynchronous spaghetti code all over the place. And Kotlin coroutines simplify a lot of that, so you can simply call this when you need to, and then it will do the right thing, sort of foist it onto a separate thread. And then the code that you write for doing this ends up being a lot easier to write and to read and maintain as well. Maybe you also figure in the new paging capability. So instead of just having a live data of the data itself, maybe you have this paged list, and then you can stream that in, especially with paging 3 using new flow capabilities. Right. So one of the things, Romain mentioned this, is a lot of these things between the tools and the APIs, they're sort of built to work together. View model, live data, lifecycle, they're all lifecycle aware. They're all using common APIs and approaches to handle all of these capabilities. To make it easier to write robust code for these complicated situations. Room uses these as well, separates the data from the UI, as I talked about in those diagrams. Room is using coroutines and flow to simplify a lot of that stuff. As I said, keep the database access off that UI thread. I should point out, too, that although some of the capabilities in the libraries that I'm talking about do replace things that some developers use, frameworks like RxJava for, it's not intended to have everybody migrate away from RxJava. If you're using RxJava, that's great. RxJava tends to be a thing that, like, once you start using it, it's probably everywhere in your code. Maybe you get other benefits out of it as well, and so we're not telling people to move away from. In fact, we have APIs that should make it easier to integrate with RxJava instead of, completely tilting over toward the live data world. We have the navigation component API as well as library. Makes it much easier to create these navigation flows through your applications by setting up the different screens you're going to navigate to, and then these actions that navigate from one destination to the next. This is, of course, backed by underlying XML code, which most of the tool stuff is. So you can edit it in the tool, or you can go in and edit the XML directly. Take a look at the fragments and the actions that are defining the navigation operations. And then the navigation operations, so you define the action in the tool or in the XML, and then in the code that you write is very simple. You just say navigate to this thing that is defined elsewhere in that tool. There are a lot of other capabilities in navigation that are worth checking out. SafeArg, so it's typical to pass bundles of data between activities and potentially fragments. Bundles aren't that obvious to work with. There tends to be a lot of boilerplate in terms of like packing the data in and getting the data out, and it's not really type safe data. SafeArgs allows that to be both type safe as well as easy to use. So it's an additional navigation library and API that you can use that makes it a lot easier to pass this data and then extract it out on the other side. Single activity is the pattern that we're recommending that people use. So traditionally, Android used these multiple activities. You go from screen to screen, it would pop up a new window. It's nice, it's powerful. It allows you to separate, these different screens of your application into these, different buckets. But it's not necessarily the smoothest UI experience, as the user is constantly taken from window to window to window in what should be sort of a continuous application experience. So we're recommending that people use single activity approach. It's not necessarily obvious from the outside how to do that, especially given people's habits of using multiple activities over the years. Navigation simplifies a lot of that. You can think of it as navigation primarily having kind of a single container called the nav host fragment, in which it swaps in the fragments that you navigate to over time. And so you have the single activity, you have a single container in which you have the multiple screens that the user is seeing over time. Navigation also makes more consistent the idea of up versus back. This has always been something difficult for developers to deal with, resulting in very inconsistent behavior on the device in terms of how applications dealt with this. We would explain to people what to do, but it wasn't necessarily obvious how to implement some of the stuff. And so different applications would handle it differently. And if you use navigation, we embed the policies and the patterns and approaches directly into the library. So use navigation, and then when you hit the back key or the up key, it just does the right thing. There's also nice support for dynamic features. If you're using this capability from the Play Store, you can navigate to something that's not actually downloaded, installed, and loaded yet, and it will do the right thing. You can sort of use this reference, and then when you navigate there, underneath, the system will do the right thing of downloading, installing, and then navigating to that thing. Really quick glance at Work Manager, the ability to run this deferrable code where you can guarantee that the background work is going to happen at the right time. It is not replacing doing things very exactly. Rather, it's providing a single API for doing the things that can be deferred. I think of it as replacing code that you probably already have in your application, where maybe you wanted to use Job Dispatcher, but maybe Job Dispatcher is not on the release that's on the user's device. So then you're going to use one of the replacements from the Play Services API or Firebase, and maybe that's not on that device. So then you back off and use Alarm Manager. Well, that capability, that sort of multi-tier approach to solving the problem is embedded directly in Work Manager. So you get a single API to do all of this stuff that goes all the way back to API level 14. You can have all of these capabilities. Let me take you through a simple example to illustrate what's going on. So let's say you have a series of things that you want to do with an image. I want to run 3 different filters on it. Each of these are independent, so I could run those at the same time. When all of those are done, I want to compress the result, and then I want to upload it. But I have some constraints. I only want to run the filtering if the battery is high enough to handle that operation. I only want to compress if there's enough storage on the device, and I only want to upload that image if I'm on an appropriate network to handle that operation. So the code that you write for doing stuff like that is you define this do work function in this worker, and then you define these constraints and say, well, I want to build a constraint that says I only want to run the following operation when the battery is not low. And then you associate the work with those constraints for each of those sub-jobs that we talked about, the filtering and the compressing and the uploading. And then you can schedule these things to either run in parallel or run in parallel and then sequentially as well. And then we're done. There's also support for foreground services, which is important if the user goes and runs another application, but you still have things that you need to do in that application, then Work Manager makes it easier to schedule foreground services so that the work can continue. Camera X, really briefly, a much simpler way of writing these camera applications, not just because it's a simplified UI for handling the major use cases that developers wanted. I want to preview, I want to analyze that image, maybe do some ML stuff on it. I want to take a picture and save it. But also it handles this huge set, this huge ecosystem of devices that we have out there. It turns out one of the complexities in writing these camera applications was not just the APIs, but the fact that those APIs were implemented slightly differently on a lot of the devices out there just because of the different camera capabilities of those phones in the wide world. And then applications didn't quite know how to do this. Like, do you hard code, well, if I'm running on this particular phone, do it in the following way. And so there ended up being a lot of workarounds in your developer application code. And Camera X is basically taking those workarounds, kind of the Work Manager approach. It's taking that code and putting it in the library itself. So you have a single API that you can use that then work across this broad ecosystem of devices. I'm going to skip really quickly through this. Here's some simple code here. So you can capture the image and it integrates with life cycles, so it makes it much easier to actually use and free the resources instead of forgetting to close the camera and then who knows what's going to happen. And then you take the picture. So much simplified API. Camera X is currently in beta, so you can check it out now, stable API, as they continue buttoning down the functionality and heading towards stable. And then at the same time, all of these APIs that I'm talking about, they're all unbundled, right? So they can work across these multiple releases instead of being embedded with the platform releases that come out on these now annual cycles. We release these things frequently, sometimes really frequently. Like every 2 weeks, there are new releases of many of the Android X or Jetpack libraries. These tend to be sort of incremental bug fix releases, the next alpha, the next beta, the next RC. There are new APIs constantly in development. Romain talked about Jetpack Compose, HILT, dependency injection library that's currently in alpha. Paging 3 went through a huge rewrite that is currently in alpha. And now I want to talk really quickly about Android app bundles. So the fourth tier is distribution. How do we actually get the applications out? So we always had APKs. We talked about that before. And then in 2018, we announced Android App Bundle. That's really quick timeline for you. Just one thing. Yes, we announced it. There it is. So if you look at the dynamic of storage and applications on devices, 30% of the phones out there have less than a gig of free space. That means that they don't have a lot of space to play around with installing your application and then installing a ton of other applications. Instead, they're probably going to end up uninstalling stuff to make room for other things. One of the dynamics that we've seen is that it's kind of obvious if you think about it, the less storage they have, the more likely they are to constantly uninstall applications. Your application is going to be uninstalled just because they wanted to try something new and they don't really have room for multiple things. So the smaller you can make your application, the more likely it is that the user is actually going to keep your application on their device. There's another dynamic where the larger the application is, the more likely it is to have some issue in installing, whether it's a download issue, bandwidth didn't get there in time, something flaky going on, or just fitting on the device or whatever it is. But again, a pretty strong argument for keeping applications as small as possible. And then finally, there's other evidence that we've seen where basically the smaller the download is, the more installations there will be, because that is one of the factors that users use in determining whether they want this application on their device. So if you look at app bundles, there's this nice diagram I like, little friendly animation to show you what's going on. The idea behind app bundles is that it's kind of like the monolithic APK approach, except with a monolithic APK, which contains everything that all of your users are going to need. That means every single user is going to get that same APK, which means they're going to get a ton of things that they don't need. They don't have that particular configuration you were handling. They are not using that locale and those languages that you embedded in your application. So they're getting all this unused stuff, which means more time to download, more time to install, more footprint being taken up on their device. App Bundle, you upload this monolithic thing, and then Play Store determines at install time what the user device actually needs, and those are the bits that it downloads. So really powerful. There's alternate ways of showing this, but let me skip those. There's pretty good adoption so far. Over 500,000 apps in production using this. 35% of the active installs now, and almost 50% of the top apps and games are already using app bundles. And the best part is there's a download savings, an automatic download savings just from using app bundles of 20% on average, right? So it might be higher, might be lower, but what we've seen in the data is on average that much. It's important to note that at the second half of 2021 of next year, it will be required for new apps on the Play Store. So optional right now, please do check it out. We think that there are benefits that make it the right thing to use now. And eventually it will be the thing that you need to use for new apps. So those were the pillars that we went over. We can summarize really quickly. We took a look at Kotlin is the language that we're talking about for modern Android development. Android Studio, of course, for the various tools that it offers and all the new features and tools coming out all the time. All of those APIs that I covered really quickly and more. And on the distribution side, Android app bundles. You can learn more about this at the Modern Android Development site on d.android.com. But also, I wanted to point out specifically for droidCon, there is this panel tomorrow afternoon. Do you like that professional graphic that I drew there, Romain? So there is a panel on modern Android development with Romain and I and many other people from the team to answer questions. We figured we wouldn't have a lot of time now, but also we want to pull in more people because there's a really broad surface area that we're talking about there. So if you do have questions about any of the stuff that we talked about or more in modern Android development, please attend the session tomorrow afternoon, your time, very early in the morning, our time. And that is it. Thanks. I don't know where we go from here. I think we're done.